Hello everyone, my name is Luis Calvo. I am a PhD student here at the University of Texas at El Paso. I had the opportunity to do a project for Dr. Calvin Stewart, and my project will be on the impact simulation of an Albatross UAV fuselage. Here's my outline. I will be talking about my motivation for the project, a little bit of background, my objectives, some geometry on the fuselage that I was working on, the boundary conditions that I set, the mesh optimization simulations, and I'll be concluding with a discussion and my conclusion. My motivation for this project is actually part of the research that I am conducting here at the university. Um, for my dissertation, I am currently working on a drone known as the Albatross UAV, and I am making configurations on changing the drone from a fixed wing into a VTOL, which is a vertical takeoff and landing, or a quadplane. For my research, it consists of testing on the fuselage or on the whole drone itself, experimentally and theoretically. For a small portion of my research that I am going to focus on for this project is the redesign of the fuselage. Currently, I am doing testing on a flight simulator as well as in real life for the impact and crash of the drone. So crashes can occur by either human error or unexpected weather conditions. So we are redesigning the fuselage in the case of a crash, just using the best materials possible and to design the best weight to strength ratio possible in order to preserve as much of the drone as possible when an unexpected crash occurs. So a lot of parts of the drone have been already 3D printed. Here you can see some motor mounts that were 3D printed, and of course we do some FEA analysis on everything to make sure that it is structurally stable. But my goal is to be able to 3D print the whole drone rather than to purchase the drone. In the case we need a new one, we can go ahead and print and we'll have another one ready in a week or so. But we are going to be changing the material of what the drone is being made out of. So when we purchase the drone, it is originally made out of fiberglass, but once the redesign of the fuselage is complete, it will be a 3D printed drone. And from the fuselage, we'll go ahead and move on to the rest of the drone from there. For this project, I'm going to be testing Nylon X as my 3D printed material. So instead of purchasing replacement parts for the drone in the case something occurs, we can go ahead and print a replacement part, and which in turn will save the program a lot of funding. A little bit of background on the project I'm working on. So I know UAVs have been recently used more and more and becoming more popular. So the purpose of the configuration of the Albatross drone that I'm working on is to again make it a vertical takeoff and landing drone, which means that it will be able to remove the need for a runway. It should be able to hover and be able to have the maneuverability of a helicopter, and from there transition to a fixed wing flight. So with there should have the endurance of a plane and then back to hover and land. Use of drones have been used for a lot of surveillance lately in law enforcement and army purposes. Um, that is part of what my research currently at the university is being done for. But they can be used for many other things. As far as surveillance, they can be used to reach places that is difficult for a man to reach, and as far as reaching places in a timely manner, in where we're limited to reach here on ground, it can be very useful in that aspect as well. My goal for this project is to be able to test the fuselage of the drone that is going to be 3D printed in order to preserve as much of the Albatross drone in the case that for some reason we are flying and a stall occurs and we have to crash land in that case. Um, my objectives are first to CAD the fuselage of the drone. That would be the first thing needed to do. Next would be to test the crash of the fuselage in explicit dynamics used on ANSYS with the 3D printed material that I had mentioned before, which is Nylon X. To start with the geometry of the fuselage, you can see some pictures here on the bottom left. of what the fuselage looks like in person. And on the top left, you can see the catted version of the fuselage at a different angle, as well as simulating it nosediving into the ground, which is, you can see that block right there. Here's some more geometry and measurements on the fuselage. It was not done in ANSYS. I did do the CAD designing in Fusion 360. As far as my boundary conditions, the angle of impact was a nosedive into the concrete. That is a worst case scenario. In the case that a stall occurs, the drone will not always nosedive straight into the concrete. Sometimes it will come in at an angle, which would be a more realistic scenario, and which would in turn allow us to preserve more of the fuselage. As far as my speed of impact, from the datasheet on the Albatross UAV, it can reach a maximum of 129 kilometers per hour. And as mentioned before, the type of material that I will be using for the fuselage is nylon X carbon fiber. As far as my mesh optimization, there were two different meshes that needed to be done. The first was for the ground. The mesh operation was body sizing, and the element size was 50 millimeters. The elements were in a hexahedron shape. And for the fuselage, the mesh operation was face sizing with a 20 millimeter element size, and the elements came out to a tetrahedron shape. Here is my mesh plot. So I did change the element size from 40 to 30 to 20. In the previous slide, I showed the number of elements and nodes in the 20 millimeter element size for the fuselage. You can see on the graph here that what I expected to see was a more linear plot, but as you can see, this was not the case. Here is the first simulation of the fuselage. The first one done was with 40 millimeter element size. I did go ahead and hide the ground, so that way we can go ahead and get a front view of the impact. And as you can see, from the 40 millimeter, we moved on to the 30 millimeter. And from the 30 millimeter, we did the most accurate reading as possible, which was a 20 millimeter. To discuss the simulations, the major outcome that I noticed were in the changes of the total deformation. While we were changing the mesh size, like I said, I did expect a linear increase in the number of elements, but that was not the case. I feel like my objective was not fully achieved, just because I am working on the student version, that is the free version. And as you can see on the bottom right, I did receive an error of energy error being too large for each simulation, which did cut off the simulation early in every change that I made. I did set it to 5 seconds, and it cut it about a little under 3 seconds. So with the energy of the impact being too large for the student version, that is the only reason I do feel that I wasn't able to fully achieve my objective. To conclude my project, my goal again was to be able to test the fuselage that is going to be 3D printed in order to preserve as much of the drone as possible in the case that a crash landing does need to occur. Again, I do feel like a full testing wasn't able to be achieved just because of the refinement. It was limited with the student version, and I wasn't able to get the most accurate results. I know that more tests could be done. They're not always going to be worst case, like I mentioned when I was doing a nosedive. So other angles and other materials could always be used in testing to compare the simulations a little bit better. Here are some of the references that I used for my project. And here is my info. Again, thank you guys for joining me today. I hope you enjoyed my project, and I hope you have a good one. Bye-bye.